All right, so let's talk about example 2. I'll let you go ahead and read the example on your own, but basically the scenario is we have 3 different types of trim. So let's start talking about trim 1. We know that the paintings have to have a width of 5 feet, and we just can vary the height. And so if I'm talking about the width, we know that this needs to be 5 feet. And because it's a rectangular painting, we know that this here needs to be 5 feet as well. And then we don't know what the height is, but for trim 1, we do know that there's 33 feet total. And so what we could do is we could take our 33 feet, and we know that 5 feet is being used for the top portion of the trim, or the painting, and 5 feet is being used at the bottom. So 33 minus 5 is 23 feet. And again, because this is a rectangular painting, we know that this dimension, these two dimensions here, have to be equal. And so what I could do is I could then take my 23 feet and divide that by 2. And so if I do that, then 23 divided by 2 is 11.5 feet. So 11.5 feet here, and 11.5 feet here as well. Awesome. So for trim 1, we have that the dimensions of this painting are going to be 11.5 feet by 5 feet. Let's talk about trim 2. We know that we have 30 feet in total. Our width still has to be 5 feet. And so again, we don't know what that dimension is, but we do know that we have 30 feet in total, and so we can do 30 feet minus 5 feet minus 5 feet. And so that will leave us with 20 feet. And then if I were to divide that by 2, that would be 10 feet. All right, so for trim 2 and for that painting, our dimensions are going to be 10 feet by 5 feet. I'm going to go ahead and let you do the last one. And basically these next set of questions are asking, like, is there a pattern that you notice? And if yes, like, what are those patterns, and can they be repeated? Well, in all of those scenarios, you're given the total amount of trim, right? And so we're trying to figure out the dimensions. And so basically the pattern that we're looking at is that the dimensions are going to be, one of them is going to be by 5 feet. And then the other one is going to be, we can just call it question mark for now, but basically the way that we've been calculating question mark is that value is equal to the total amount of trim and notice in both of the scenarios what we did was we subtracted 5 feet twice, which is another way of saying subtracting 10 feet. And then I'm going to put a set of parentheses around that. And then after that, when we subtracted it, what we ended up doing was we ended up dividing it by 2. And then our overall units for that was feet. So that's the pattern. That is how we figure out the dimensions. It's 5 feet by this kind of like little formula thing here. So let's go on and move on from this example to talk about representation. You know, you've probably been hearing a lot about representation lately in the news and things like that, and like our ways of life. So representation is really important in like media and movies and things like that, as well as like politics and government, but representation is important in mathematics too. So we have these linear equations and they can be represented in different ways. And one of those ways is this t table that we have here. And we've kind of used some tables previously, and we've normally called the input variable x and the output variable y. And so we want to try to figure out a pattern here. What's really nice is these input values are increasing by 1 for the first few rows, but then notice that it jumps from 3 to 10. And so it's probably not going to be the case. Notice here, what's the pattern here? We are jumping by 3. But because on the left-hand side, it's jumping not by 1, but by 7, it's probably not like this value here probably won't be 13, right? What we can do is we can develop our linear equation to help us figure out what goes in these spaces here. And so if we're talking about a linear equation in slope-intercept form, remember it's always going to be y equals mx plus b. And we want to figure out our slope. Notice that because these are being incremented by 1 and these are being incremented by 3, our slope here is 3 divided by 1, which is essentially 3. And you can think about that in a few different ways. Let's use the slope formula that I talked about in an earlier video. y2 minus y1 over x2 minus x1. And so let's come over here. Maybe I'll call this one x1, y1, x2, y2. So if I plug those into my formula here, then I get 4 minus 1 over 1 minus 0, which is going to be 3 over 1, which just equals 3, which is the same thing that I saw here. And I really didn't do any math to figure that out in the beginning. Remember, slope is the constant rate of change. And so as we increment our x value by 1, our y value is being incremented by 3. So that's how I knew that this was our slope. So if I go back here, I'm going to have y equals 3x plus, and then here we have the ordered pair 0, 1. And so the y value in our y-intercept is 1, and so that's going to go here. And that's basically our b value. So now that we have our linear equation, we can go ahead and plug these x values in to figure out our y values or our output values. So let's go ahead and plug in 10. So if we do 3 times 10 plus 1, that's equal to 30 plus 1, which equals 31. And so 31 would go there. I'm going to go ahead and now do it for 3.25. So that is going to give us a value of 10.75. I'm going to go ahead and let you do the last one on your own. So go ahead and plug that in and see what you get. I filled in our tick marks for this XY plane just to save us a little bit of time. And we want to graph these. So here's 0, 1, that's going to be like right there. 1, 4 is going to be like right here. 2, 7, it's going to be like right there. 3, 10 is going to be right there, and 3.25 is approximately 10.75. And then our last ordered pair is 10, 31. So that's about right there. If I plotted these correctly, it should form a straight line. So it looks like I was on the struggle bus a little bit, but it should look something like that. And I'm going to go ahead. This isn't a word problem, and so there aren't really any restrictions as far as like negative or positive values. So I'm going to put these little arrows on the end to indicate that it's going to go on forever in both directions. All right.